Hello, everyone. This is your speed and velocity lecture, starting with the topic of motion is relative. What does all motion is relative? This was your question of the day from earlier this week. So if you don't have that answer filled in yet, you'll be able to at the end of this slide. Motion of objects is always described as relative to something else. For example, you walk down the road relative to Earth, but the Earth is moving relative to the sun. So in other words, if your perspective point is the sun and is something moving relative to the sun, that means that if you are the sun, is the object moving, right? So the Earth is moving relative to the sun, and the sun is moving relative to Earth. It just depends on the perspective point. If you are sitting on Earth, you are not moving relative to the Earth, but you are moving relative to the sun, the moon, the solar system, etc. So it just means that motion can only be described with a specific vantage point in mind. So you have to say from what perspective is the object moving. Things are not just definitively moving or not moving because literally everything is moving relative to something else. So it depends on what your perspective is. Most of the time in physics, we are referring to Earth as our perspective. So we're saying the Earth is not moving and everything else is moving relative to the Earth's motion. So generally speaking, that is what the reference point typically is the Earth, but it does have to be defined. Next, we have speed. So you worked with this yesterday in the lab where you're measuring the motion of different animals. You took the distance over the time, and that's what speed is. So the common units that we're used to hearing are miles per hour, or mph. Miles is a unit of distance, so you have speed equals distance over time. The common in America, we use miles per hour. So miles is a distance, hour is a time. So the distance divided by the time gives us the speed of the object. An example would be a girl runs 4 meters in 2 seconds. Her speed is 2 meters per second. So we would take 4 meters and divide it by 2 seconds. 4 divided by 2 is 2. And meters divided by seconds is just meters over seconds because that doesn't cancel out. So our final answer would be 2 meters per second. So over here I have another example for you to try. The distance you travel is 50 meters. It takes you 5 minutes. What is your speed? So you can leave the unit of time in minutes. You don't have to change it to seconds. Minutes is fine. So what would be the speed in meters per second? What would be that answer? So we're going to take a moment to solve that problem and put it in the box. Next, we have average speed. So we're going to talk a little bit about average speed versus instantaneous speed. That was your QOD yesterday on Tuesday. And so I'm going to go over that right now with the difference between average speed and instantaneous speed. So first of all, average speed is the total distance you're going to cover over the total time it took you to do that. Now, if you've ever been on a road trip, you know that you do not go the same speed the entire time you are driving. You stop at the gas station, and so you're going 0 for a while. Then you're on the on-ramp to the freeway, and so you're going from 0 to whatever highway speed. Then as you're driving on the highway and a truck pulls in front of you and you have to slow down, and then you need to pass somebody, so you speed up. So the entire time you're going various speeds. But if you want to know your average speed for your trip, you would take the total distance over the total time it took you, and that's your average speed, meaning that you're not necessarily going that speed the whole time. You may have moments where you're going exactly that speed, but it's taking into account all the speeding up, slowing down, stopping, etc., that occur on the entire trip. So you have a sample problem that says you drive a distance of 200 kilometers in 2 hours. Your average speed is 100 kilometers per hour. When you drive to school, you travel 1.5 miles. On Monday, it takes you 7.5 minutes. What is your average speed? So remember, when you drive to school, you don't just go the same speed the whole time, right? You're stopping at stop signs, you're turning corners, you have to slow down because someone is in front of you, or you speed up because there's no one in front of you. And you stop and go when you're waiting in traffic. You're going a little bit, driving really slow and then stopping and slow and stopping. And so the average speed is just how far did you go over how long it took total for you to get there. So you're going to divide 1.5 miles by 7.5 minutes to get your average speed. The second question says, when you drive to school, you travel 1.5 miles. So same as on Monday. On Tuesday, it takes you 5 minutes. What is your average speed? So this time you're traveling the same distance because you're going to school, same path, but it takes you less time on Tuesday. So what is your average speed on Tuesday? Next, we have a content check here. The average speed of driving 30 kilometers in 1 hour is the same as the average speed of driving 30 kilometers in half an hour, 30 kilometers in 2 hours, 60 kilometers in half an hour, or 60 kilometers in 2 hours. So remember, we find average speed by taking the total distance divided by the total time. And so the average speed of driving 30 kilometers in an hour would be 30 kilometers per hour. Let me write that. So it would be 30, forgive the writing on here, it's absolutely terrible, km, so kilometer over hour. So that would be the average speed of up here for this information. And then you're trying to find out which one of these would be the same. So A would be 30 divided by 0.5. So you would use the decimal form. 30 divided by 2, 60 divided by 0.5, or 60 divided by 2. Which one of these four gives you the same number of 30 kilometers per hour? And put your answer choice there. Next, I'm going to distinguish what instantaneous speed is. So instantaneous speed is the speed you would see if you look down at your speedometer in your car. So it is, so this one right here, if you look down at the speedometer, at a given moment, how fast are you going? How many meters per second? How many miles per hour? So if you are driving on the freeway at a constant speed and you look down at the speedometer, that is your instantaneous speed. If you are stopped at a stop sign and your speed says 0, that is your instantaneous speed. So remember that on any trip, you might be going, let's say this is going 0 and this is going 60. So I'll put that there. At any given time throughout your trip, you might be going 0, you might speed up to 60, you might have to slow down, speed up, slow down, speed up, come to a stop as you exit the freeway, drive down a surface street so you're not going as fast, speed up, slow down. So your speed at any given moment can change. The average speed just says total time, total distance, total time. Instantaneous speed can be any speed in between, any moment in time. So if I said right at this spot, what is your instantaneous speed? Well, it looks like, based on this very rudimentary graph, that would be about 20 meters per second or miles per hour. So instantaneous speed is just simply what is your speed at that moment. It isn't necessarily indicating how far you went and how fast you got there. It's just in the moment, what is your speed? So I give an example of an instantaneous speed you will definitely have when driving across town. Hint, red things. So think there's two things that it could be, right? Stop signs and red lights. Velocity. So velocity differs from speed slightly. Velocity has two components. It has the speed and it has direction. So you have speed and you have direction, speed and direction, speed and direction. All right. So you have the amount of speed, so meters per second, miles per hour, and the direction, north, south, northeast, 50 degrees north, whatever direction. It is a combination of both the instantaneous speed of the object and the direction of travel. So if I am saying I'm traveling northeast by a certain number of degrees, then I would indicate that in my velocity, I would say meters per second and then direction. So just like in force, where we had to do like 5 newtons left, 5 newtons right, vectors require a magnitude, an amount, and a direction. So velocity is essentially speed plus direction. When you're driving to school, you're driving all different directions. But if I were to look at a map of your, like, so let's say this is a map of Stockton, and this is your house, the green dot, and school is the purple dot, and your path is yellow. So if to drive to school, you might have to do that, right? Velocity would be point A to point B in a straight line. Well, that's not super straight, but you get the idea. Speed is all the journey, all the distance you traveled and over the time. Velocity only takes into account the total distance over the total time from point A to point B. So in a straight line, that would be considered your velocity. We'll talk more about that later as well, that just to get you started. And then what are the two parts of velocity? Speed and velocity. Constant speed is steady speed, neither speeding up or slowing down. So the word constant means it's not changing. So it's the exact same amount the whole time. Constant velocity is constant speed and constant direction. So no turning. If you have turning, you are changing velocity because velocity is constant speed and constant direction. And if either of those change, you have a change of velocity. And we define that as acceleration, actually. And we'll be getting into acceleration more in a few days. Motion is always relative to Earth unless otherwise stated. And that just is to keep things simple. Place each item into the speed or velocity category. First, 50 meters per second. Second, 25 miles per hour. Third, 40 meters per second to the north. Fourth, 20 centimeters per second to the left. So 2 of those are speeds and 2 of those are velocities. Look at the definitions and match them. You drag them by clicking on the little compass symbol and dragging them into the boxes that they correspond to. So speed is quantity only, distance per time, and velocity is distance per time plus direction. All right, in our lab tomorrow, you're going to be graphing your data. And so I want to go over parts of a graph here for a second. So number 9, what is the x-axis or the run label? So the x-axis is the one down here across the bottom. It is also called the run. If we're talking about slope, we say the rise over the run. And so this would be the run, the x-axis. Then we have, and you can see right here what that label is. You just type that into the box for number 9. Number 10, what is the y-axis or the rise label? And it says right here, distance from start in meters. Number 11, calculate the change in y. Change in y is final y minus initial y equals change in y. So you're going to select a point. So for example, let's use purple here. And let's say I'm going to pick this point right here. Oops, it's not letting me. Hold on. So let's say I'm going to select this dot. And let's see this dot right here. And I'm doing that because those are right on the lines, and that's a little bit easier to calculate when you use points on a graph that are right on the crosshairs. So calculate the change in y. Final y minus initial y equals change in y. So final y would be the one that is further along in time. So here we have y is equal to 4, and the initial is equal to 2. So we would have 4 minus 2 for change in y. Calculate the change in x. Final x minus final x minus initial x. So this would be our initial x, and this would be our final x. Okay, so initial and final. And for the y, this would be final and initial. So we would take, so we end up with a change in y of 2, change in y of 2, and a change in x of 8 minus 4, so 4. Last, we find the slope, which is the change in y over the change in x. The change in y was 2, the change in x was 4, so 2 divided by 4 gives us the slope of the line. And I'll let you do the last calculation on your own. All right, I will be handing out the handout for this lecture on Friday for you to put in your notebook. At this time, just make sure to finish the all 13 questions in the Go formative and submit that. Make sure your answers are correct, and complete and submit the Edpuzzle that is posted as well. Any remaining time you can spend completing your lab. The lab is expected to be completed today. If you need more time, please let me know, but otherwise that is the expectation, that you complete the previous lab. All right, thank you, and see everyone on Friday.